Okay, pre-calc. This is the second part to section 3.4 that was cut out of the last video. So in the first video, you learned how to find inverses graphically. I went over the horizontal line test. And then the second learning target was how do we find inverses algebraically. And then the third one is the verification part. So we'll start here. Two functions are inverse functions if and only if their compositions equals x. And so you're going to have to do like two composition problems, and if both of the problems' answers is equal to 1x, then that is proving that the two equations given to you are actual inverses of each other, meaning they're reflections over the y equals x diagonal line. So we have f of f negative 1x is equal to f negative 1 of f of x. And again, this is just putting in algebra terms exactly what the sentence above said. So your example is to find, for number 1, find the inverse of f and then verify that the two functions are inverses. So the difference in this example is that I just gave you one function and I'm asking you to find the inverse, what you think it is algebraically. Then once we get that answer, we'll call it f negative 1 of x. Then we're going to take both equations, both functions, and verify or just prove that they actually are inverses. So the first thing you do always is change your f of x or g of x notation to y. So it's going to be y is equal to 4x minus 9. And then we're solving this out, trying to find this algebraically. So you're going to switch or interchange the letters. So now it's going to be x is equal to 4y minus 9. And again, you're keeping your eyes on the y because you're solving for it. So that means we're going to need to transpose. So it's going to be x plus 9 is equal to 4y. Okay, the next step would be you showing that you divided everything by 4. And what I'm going to choose to do on this side is just, instead of dividing x by 4 and 9 by 4, although that would work, I'm just going to leave it as one big fraction, because I think it might be easier to use the one fraction in the verification step. And so it looks like now, we'll switch this back to the f notation, that the inverse that we just found algebraically is equal to the quantity x plus 9 all divided by 4. Alright, so that's what we think the inverse is, and I'm going to actually highlight both of these. So we've got the f of x, the original function's 4x minus 9, and then we have what we think the inverse is x plus 9 divided by 4. Now we're on to the verification step. Again, you only show the compositions if the directions ask you to verify or prove that two functions are inverses. So the notation, we're going to start with this one first. We're going to do the original function, f of inverse. We're going to combine or compose those functions and see what answer we get. Okay, then we will do the opposite of that. We'll do the inverse on the outside. We'll do a composition on these two in a different order, and then we'll just see, are they equal, and if so, are they really equal to x? Because if they're equal to 1x, then it is a guarantee that they're inverses. So we'll start with this one. Again, follow the lettering. Here's your original function, and here's your inverse. On this side, notice the inverse is outside the notation, and the original is on the inside. So let's start with this problem. We've got f comes down. You're going to fill in the inverse that you just found, and that was x plus 9, all divided by 4. Okay, we're just going to continue to work down the page. Now this says go to your f function, and where you see x, replace it with this quantity. So the rule for f is 4 times something minus 9. So it's going to be 4 times that quantity minus 9. And then looking at it from these are two fractions basically. 4 is 4 over 1. When you're multiplying fractions, you usually just go straight across. But also a shortcut that you may have learned earlier back in the middle school level is when you do have fractions, if the numerator on the one fraction is the same as the denominator of the second, you are allowed to simplify those. So that's 4 divided by 4, which is essentially 1. So in this case, I'm just left with x plus 9. And technically that's all being divided by 1, but dividing by 1 obviously doesn't change anything. So I'm just going to leave the divide out. Drop my minus 9 down. And then I have x plus 9 minus 9. 9 minus 9 is 0. So now I'm left with just x. So that's a good sign because that's according to the actual definition for inverse invarification. This should be the case. Okay, so I got an x. Okay, next I'm going to do the second piece, and that's going to be the blue part. So we're going to drop the f negative 1 down. Okay, we're then going to put your f of x function in here. So we're going to write 4x minus 9. Okay, now you're going to drop your f negative 1 down. Oh, sorry. We don't have to do that. We are ready to actually substitute. So we're going to go to the inverse function, which is here. Where we see x, we're going to replace it with 4x minus 9. So we're going to draw big division bar. Here 4 goes on the bottom. Something plus 9, you're going to drop this down as 4x minus 9, and then plus 9. Okay, and notice in the numerator of this big fraction, we have these two values that need to be combined. Negative 9 plus 9 is 0, so you're left with 4x on top, and then a 4 on the bottom. 4x divided by 4, the 4's cancel, or leave you 1, and you're left with x. And so we can see that both composition problems gave us x. They are obviously the same value. More importantly, they equal what it's supposed to. And so after we did the find the inverse of f, and now we're verifying, we can finish the question by answering it and saying yes, these are inverses of each other. And so that's how you're basically going to do the last set of problems. Again, only use this technique when the directions says to verify.